Azure Traffic Manager, and it is a very simple topic, and it's very easy to understand. The only thing is, if somebody is asking about Traffic Manager, you should be able to explain them what are the routing methods of this Traffic Manager and where do we use them. So I will start with one example. Okay, here there is one application, Contoso is one of the application, and the users are spread across the world. Some are in USA, some are in Europe, some are in Asia, and and uh, and the product owner want that the application should be accessible across all the regions with a low latency. If suppose I am hosting my application in USA, the the users in USA, they will be able to access it so easily. The latency will be low. If the same application which is hosted in USA and users from Asia are trying to access, there will be a latency because that request packet has to travel all over from Asia to USA, and it has to respond back. So there will be a round trip latency, right? To overcome such kind of issues, so this traffic manager is one of the component which can help in that kind of issues. Okay, here the Contoso.com is one application. Okay, and what the user has done it, he has deployed his application in USA, Europe, and Asia. In three different regions, the same application is deployed. The same version of application is deployed, and he has, on top of these three application, he has kept Traffic Manager. So what is happening? If somebody is trying to hit Contoso.com, the request is not going to the application directly. In between, it is going to the Traffic Manager. Then it is trying to distribute or send the request, forward the request to the appropriate location. I will show you.
Okay.
Yeah. So this is how the clients are connecting using Traffic Manager. So it has point to point how the request is flowing between a user and the web app or the endpoint. First, the user is trying to browse. The request is going to the DNS server. In the DNS server, what he finds a record. Okay, Contoso.com has a CNAME, contoso.trafficmanager.net. So that means whatever the requests are coming to Contoso.com, this canonical name, contoso.trafficmanager.net, sh- the request should be forwarded to this. So now the request is flowing to, once it got resolved at DNS service, it is going to Traffic Manager. Then in the Traffic Manager, uh, it is trying to, and so depending on the routing method, we have configured this Traffic Manager. So there are different routing methods in Traffic Manager. So each routing method has some logic. Okay, we'll be covering what are routing methods. Okay, so that routing method will take the input, user inputs, go through the logic, and it says now you have to, the request should go to Europe app, which is hosted in Europe. Okay, this contoso-eu.cloudapp.net is the endpoint in Europe. So now it is going back to the user that the user has to reach out to this endpoint. Now the user got the endpoint name. Now the user is directly connecting to the web app or the endpoint which is in East US. So basically, you see there are two flows. One is this way, one is this way. The first way is still Traffic Manager. Traffic Manager responds with the endpoint you have to reach out depending on the routing methodology. Then the second step is the user will reach out directly to the endpoint. Any questions on this flow?
No.
Okay, so some overview on Traffic Manager. So Azure Traffic Manager controls distribution of user traffic across multiple application endpoints. Endpoints can be any internet-facing services inside or outside Azure. You can also add um, endpoints from on-premise as well. It operates at DNS level. So you see the mm, the names it is forwarding, right? Even at the
Yeah, the
endpoint,
CNAME.
yeah, CNAME and also the endpoint name, it is, the user is provided with the endpoint URL. Okay, and it works on application layer, layer 7. The key benefits are it has some traffic routing methods. Based on that, the user is guided to reach out to the endpoint and monitors endpoint health and performs automatic failover. So it monitors the endpoints and it does the automatic failover, same like the other two um, networking components. So now let's see. Yeah. So now let's see. This is one important thing, as I mentioned. Though it is a simple topic, we need to remember these routing methods. Okay, it has 6 routing methods. Earlier there were only 4. I think recently they added 5 and 6. The last time when I learned and I was giving like I was covering this topic, there were only 4. The first 4, 5 and 6 are
Okay.
recently added. Even when I checked the learn.microsoft.com, which I generally refer for making slides or going through labs, I generally depend on the Azure Learn. So these two, 5 and 6, are recently added. I don't see any diagrams or much content on that. Okay,
Okay.
first 4 are something, it covers most of the things, most of the required routing manager methods, traffic manager routing methods. We'll cover one by one. First one is priority, second is weighted, third performance, fourth geography. 5 and 6, multi-value and subnet. We'll go with first one, priority traffic routing method. You see this diagram, the same diagram which we saw earlier. The request is flowing to traffic manager. Then the user is provided with the endpoint. Endpoint, the user is trying to directly browse the endpoint. So the user has placed the request. So it is getting resolved at traffic manager. So what traffic manager will do? So it has to use the routing methodology and provide the user with the endpoint. So what is this methodology or the logic he will use here? It depends on the configuration you keep on the traffic manager. If you put priority routing method, so once you try to configure the priority routing method, what happens? You need to add endpoints in this way. So I want to send most of my traffic um, to the primary region, and I give the priority as 1. And this is a failover A, failover B, second priority, third priority. So I want most of the traffic to go to the primary. If it is not working, then go to the failover B, for failover A. Even the failover A is not working, then go to failover B. That's how you have configured.
Okay.
So what it said, select priority routing when you want to have a primary service endpoint for all traffic. You can provide multiple backup endpoints in case the primary or one of the backup endpoints is unavailable. So that's how the priority works. You decide which endpoint should be given priority, which endpoint should take the maximum user
Okay.
requests.
Yeah.
So in this case, the user will be provided with the primary. If it here, I think it is degraded. So the second one is online, failover A. So this primary endpoint is down. So now the user is directed to the failover A, which is priority 2. Next is a weighted traffic routing method. So here in weighted traffic routing method, when you want to distribute traffic across a set of endpoints based on their weight, set the weight the same to distribute evenly across all endpoints. The higher the weight, the higher the priority. So higher the weight, higher the priority. Means if you see the number, region A is given weight 50, region B is also given weight 50, whereas test A is given 5. That means if there are 105 requests, 50 requests will go to A, 50 requests will go to B, and 5 requests will go to test A. Okay, so basically, higher the weight, higher the priority. So here, both the region A and region B will take the equal number of requests. Some requests, like very less of requests, will go to test A. And in this case, test region A is degraded. So for some region A is degraded, it is not online. Then the request will be left with only two of the endpoints, test A and region B. And now out of these two endpoints, this has high priority 50. So most of the requests will go to the region B. And even if region B goes down, it goes to test A. So this region A in the diagram, if you see, this is down, and now it is going to region B. The flow will work in the same way. The user first will reach out to traffic manager. Traffic manager will tell user, you need to reach out to this particular endpoint, and then user will directly connect to that endpoint. Everything happens in the backend. We won't be able to understand to which endpoint we are connecting. The one way around we can check is, so as a DevOps engineer or the cloud engineer, the one way around is to check is you can do with NS lookup space the traffic manager URL. Then you get a response with which endpoint you are trying to connect. It will say region B endpoint. So when you
Yeah.
try to do NS lookup with the traffic manager, there in that response, you will be able to see to which endpoint it is, um, to which endpoint it is trying to resolve. So this is the second routing method. Third one is a performance traffic routing method. So select performance routing when you have endpoints in different geographical location and you want end users to use the closest endpoint for the lowest network latency. So we choose the different endpoints in different geographical locations, like the one example which I showed earlier, the contoso.com. The users are across the world, and you have the application endpoints, one in US, one in Europe, one in Asia. So in this scenario, if we configure traffic manager with performance routing method, it will try to maintain a table. So if you see, the closest endpoint isn't necessarily closest as measured by geographical distance. Instead, the performance traffic routing method determines the closest endpoint by measuring network latency. So what he is trying to say in this line is that it necessarily um, it doesn't mean that um, the endpoint is near to the user is near to the nearest Azure data center. It what traffic manager do when you set this traffic routing method, it will maintain a table. Like if you see, the West US region is responding with 15 milliseconds, North Europe 75 milliseconds. It is not calculating the distance here. It is calculating TTL or the network latency. So the round trip it is taking to resolve that request is 15 milliseconds. So it will send to the West US here because the network latency is very less. So that's what it
Oh,
is trying to say. Yeah. So endpoint by measuring network latency. Traffic manager maintains a internet latency table to track the round trip time between IP addresses and each Azure data center. Traffic manager maintains an internet latency table to track the round trip time between IP address range and each Azure data center. So this performance is maintaining one table. Okay, and here there is a third one, 150 millisecond. So now if West US is going down, here West US has gone down, which was actually responding with the minimal latency earlier. It has gone down. So now out of these two, North Europe and East Asia, the network latency is very less in North Europe. Now the request will go to endpoint 2 with North Europe. So the same methodology, the traffic manager will come here, the request will go to traffic manager responds with the endpoint URL, and it directly goes to the endpoint, directly hits the endpoint in the second step. So this is about the performance traffic routing method. The last one, or I will say one of the important one uh, out of four, and there are other two, but anyhow, um, we'll cover this one in detail. Okay, this one is a geographic traffic routing method. So by name itself, you understand geographic traffic routing method. Select geographic routing to direct user to specific endpoints, Azure external or nested, based on where their DNS queries originate from geographically. So if I'm trying to hit, for example, facebook.com, right? So Indian user uh, is trying to hit Facebook, and my request is originating from India, and the DNS query is going to one of the router which is in India. So based on that, it will send the request to the application or the endpoint which is hosted in that region or nearest to this region. Okay, so that's how this will work. With this routing method, it enables you to be in compliance with scenarios such as data sovereignty, mandates, localization of content, and user experience, and measuring traffic from different region. So here, this line may look complicated, but I will try to explain it in simple way. If, for example, if you take, there are some sites let's take a few countries like Russia, China, n- uh, n- North Korea. So they have some website. They don't want to, expose them to countries which, out of their country, and they want to make sure only the users who are in their country will be able to access such content. Okay, so in that scenario, this geographical traffic routing method will help a lot. Okay, some content, government related websites or something like that, they want to restrict to that region only. In that scenario, we can use this traffic routing method. So there are some data sovereignty mandates, localization of content and user experience. Localization of content and user experience. Like for example, we'll take Amazon.com. So I get to see all the products which are being delivered within India, and you may get to see some of the um, products which are nearest to your region. So that kind of experience uh, can be uh, can be given through this routing method. Okay, here there are three endpoints. Okay, assigned geo. Endpoint one is Germany, nested profile Mexico and Asia. Endpoint two is throughout world. So here nested profile means again there is one traffic manager here. You see here there is one traffic manager. Again there is a endpoint one, endpoint A and endpoint B. One is in Mexico, one is in Asia. So this is a nested traffic manager. We can also configure like this. Now what is happening? Choose the endpoint that is designated to serve the user geographic region based on the DNS query source IP address. So once you configure this and the user is coming, suppose it is from Asia. So Asia is part of this nested profile, right? And here also you have configured geographic traffic routing method, or anything else is also fine. But basically this will understand this is from Asia region. So the request will come here and this gets resolved. Here, instead of direct traffic endpoint, here it will give the traffic URL, traffic manager URL. And this traffic manager URL again resolve this to one of the endpoint. And third one is world. That means anywhere in the world, if somebody is trying to reach out, it goes to that one. So here, Germany, I think it is given as Germany because data sovereignty mandates. If Germany has some laws, so they want to maintain that. So only the request from Germany, um, users from Germany will be pointed to endpoint one. Rest all will be, moved, the request will be sent to the nested profile or endpoint two.
Got it. Got it.
Yeah. So this is the fourth one. And multi-value and subnet. So multi-value, select multi-value for traffic manager profiles that can only have IPv4, IPv6 addresses as endpoints. When a query is received for this profile, all healthy points are returned. So multi-value will return uh, traffic manager profiles. Okay, traffic manager profile will return the multi-value. That means two or three addresses it will return, two or three endpoints it will return here in this query. And the will get a chance to, user will be forwarded to, one of the endpoint. And here in the subnet, select subnet traffic routing method to map sets of end user IP addresses ranges to a specific endpoint. When a request is received, the endpoint returned will be the one mapped for the request source IP address. So based on this endpoint end user IP addresses, it will be forwarded to one of the subnet endpoints.
Okay.
And um, these four are important: priority, weighted, performance, geography, multi-value, and subnet. You should have some knowledge. Okay, you should at least be able to say, okay, these are there. These are most configured one. I mean, I have seen people configuring this, and we were using performance. Um, when I was in this Microsoft project, I was using this performance-based routing.
I remember using geography because
Okay.
we were having offices in Canada, US, and India. So I remember we were having traffic manager routes towards the one, but not configured. But remember that we had that performance one and the uh, priority one.
Okay. Okay. And it's very easy to configure. Have a lab, okay, and this one is in Learn. It has all the steps. So I'll put this.
Yeah, it's a pretty straightforward steps to create it. I remember doing it.
Yeah. So it has multiple tutorials if you go to learn.microsoft.com. The first one has the basic setup, like it will create two VMs, which has IaaS. Like yesterday, we have created VMs with IaaS, right? Same way.
Yes.
And two test VMs will be there. Test VMs are just to check to which traffic manager it is going. Here, the two VMs, what he has done, one he has created, one VM he has created in East US, one VM he has created in West Europe.
West Europe.
Yeah, and these test VMs also he created one in uh, East and the other one in West Europe. Okay, and he has configured DNS name for the VMs running IIS. Then he configured traffic manager. So for this lab, what I have done, and now that it was taking time to configure VMs and create four VMs, I need to create, right? A
Yeah.
DNS label also I need to create. I have already created them. I will show you what we have created. So I'll come back here. And if you see the virtual machines, this is my IaaS VM. IaaS VM means it is hosting my application. This
Mm-hmm.
is in East US region,
Issues. Yeah.
and this has this public IP address. And this is in West Europe. And here, resource groups are different. Both are in different region. This is in West Europe, and this VM,
Yeah, because the regions are different. That's
yeah,
why we need to split the resource groups too. Yeah, I remember. Understood.
yeah. One thing I would like to mention, it's not necessary that if resource group is in East US, then we have to keep all the regions or all the resources from East US only in that region. The resource group is like a logical container. You can add the resources from different region also. It will allow you to add, but how you want to keep the resources for easy understanding, it's up to you. Here we have
Yeah.
created, so
Separating them will make us easy on a day-to-day operations because of the rules, firewalls, subnet enables, and all the stuff. So the best practice would be separating them. I remember somewhere I read long time
okay,
back.
okay, yeah, that is one that is one good point. Yeah, that helps for routing methods and network configuration. Here for this lab, so we just followed what the Microsoft has given the steps here. So he mentioned to create two different VMs in two different regions, and here the resource groups are also different. And public IP addresses we have created, and similarly test VMs I have created. Um, East to US one in this resource group, and West Europe one in this resource group TM2. So basically this IIS VM and a test VM. So these two are in the same region. Similarly, West Europe IIS and West Europe test are in the same region and same resource groups. So the next thing he is trying to explain is, so once you have created the VMs, configure DNS name for the VMs using running IIS. What does that mean? If I go to one of the IIS VM, it has public IP address. Unlike the previous labs, this time we have configured this VM with the public IP address. So what it does, it helps us to log into this VM using this public IP. And what we have done is, so you can name this public IP address with one of the DNS label. Here, the DNS label is, I just gave this name, my ISVM, same as this, East US. Then it was not available actually. Then what I did, so if I click that, DNS label is already taken. This label is already taken. The full name will be like this. FQDN is myisvm east us dot east us dot cloud app dot azure dot com. Now that to check available one, I just added today's date 0511. So that was available. So now if I want to connect, I can also connect using this DNS label. Basically, this DNS label is like a record. This will go to this IP address. Yeah, are you getting me?
Yeah.
So I just did that. So basically, this will help when you try to configure Traffic Manager. So how it will help? Let's see. Let's see. Traffic Manager. I will go ahead and create Traffic Manager. You can create this Traffic Manager in any of the regions, either in TM1 or TM2. And I will say this is my Techlines app VM, app traffic manager, TM is traffic manager. This is available. And here you get the option to choose the routing method. So I will choose performance. By default, it is showing performance. If you want to choose geography, also you can choose anything, whatever you want to choose, you can choose here. And you just need to go ahead and create. That's all. And once this traffic manager is created, then you can add the endpoints and configure the traffic manager. So create a traffic manager profile for improved website performance. So we'll just add the VM endpoints to the traffic manager profile. And at the last, we just do the testing, view traffic manager in action. So this is ready. Mm, Traffic manager profile, and here you can see the option endpoints.
Points.
So we need to
Now
add,
we are in VMs.
yeah, adding we endpoints, and the name I can give. I will add West Europe, VM West Europe. So here the targets can be any of this. You can add a cloud service, app service slot. So in app service we have slots also, right? Multiple slots we can
Yes.
create.
Yeah.
Production, test, UAT, all slots we can create. You can directly select slot also. Here I will choose public IP address. My VMs are having this public IP now.
Yeah.
So once I click on the drop down, I can see my DNS name, my ISVM West Europe. So this one I will select. So I will not add anything here. I'll just go ahead and add. So this monitoring status, so it is now the traffic manager is trying to check the endpoint. After some time, it should come online. So that means the traffic manager is able to hit this endpoint. And once it is online, then only this traffic manager will be able to respond back to the user with this endpoint details, or else it won't respond. So
Got it.
if some issue is there with one endpoint only, you have to come here and check whether the status is online or not. I'll go ahead and add the second endpoint. And I will say it's not West Europe, this is East US. And I'll say public IP address. And I'm adding the second one. Click on add. So this is how you will add the configuration. Once you click on configuration, you can also make changes on the routing methods and all you can change. So here we have selected performance. So it says time to leave is 60 second. Protocol it is using to check is HTTP. Port it is using is 80. Path is this. Probing interval is the heartbeat or the ping request it will send to check whether the endpoint is up and running. So it tries 3 times. If it fails more than 3 times after 10 minutes, probe will timeout. And after 3 retries, it says that the endpoint is down.
Got it.
Similarly, you can change to waited. So I'm not sure, will it give the other options? Okay, let me try. If we are putting waited, then saved successfully. This is also same. And in the waited, we give the values, right? So the endpoints. So here the wait by default it is giving 1. So I want to change weight, like if in our this is weighted, right? We give 50 to one and 5 to other. So that
Yeah.
value you need to decide. So to which one you want to give high weight. So that means you are making one of them as a primary.
Yes.
If you evenly want to distribute, you can also increase this weight here. So that's how that will work. And priority, I will say save. Go back to the slide. The next one is priority. So you are giving priority to these endpoints.
Yeah.
L1 it is giving, you are giving 1, 2, and 3. The same option will be there if you go to endpoints. You can change the priority. Here it has by default, it has given priority to West Europe and 2 to this. If you want to change, you can change. Just you will be able to edit. I'll make it 3. So it has updated to 3. You can change the priority. Similarly, we'll try the last geography, uh, and I'll go to the endpoints. I think it is not allowing to change. Let me retry. I think there is, I think it won't allow. Let
Okay,
me
once we
try.
configure it, it's not gonna allow to change it.
Yeah, looks like that. Finding solution for failed to save traffic manager profile. It will explain us. So in build, we have this copilot. If something gets failed,
Yeah.
like in the notifications, we can also check here. So now I think it is trying to troubleshoot or do something.
Yeah, it's gonna give us an option saying what went wrong, what need to be changed.
Okay.
It's like it compares and gives us the options what need to be changed.
Okay. Now is it checking?
Yeah, it's giving an option. See. Yeah, it verify what went wrong and it's giving an option why it went off to verify these steps.
Okay. Ensure your traffic routing manager profile is set to use a geographic routing method. Assign geography for each endpoint in your traffic manager. Assign to list one.
Yeah,
Use.
while creating, I think we created the first one as geographic, right? So that's why it's pointing back to create as back. Go back to geography. While creating this, initially we created geography, right?
I think we did it as performance. Mm. Okay, let me try last one time. I'm not sure. I don't think it will help us. Okay, it's failing. So one thing I feel that maybe if we are configuring this um, with some other routing method, it may not allow us to change like how we were able to move from performance to weighted or performance to priority. It is not allowing us to move to geography. So maybe initially itself we should be able to change it, or maybe we will be able to do it from I think from command line. Maybe we will be able to update.
Maybe.
So yeah, once these are all priority and everything is configured. So here in this example also, he's creating VMs. I'll go directly to the traffic manager profile. So here he is trying to create a traffic manager profile. He has selected the performance. So yeah, here is the name, and he has selected, where is this traffic manager performance routing method. And then he added the endpoints, and he has chosen the endpoints like the public IP addresses. And you see this monitoring status is online. So they are online here. Then afterwards, he is trying to log in to one of the VMs and trying to hit them. Here he has logged into the East US VM. my VM East US is one of the test VM. He logged in and he tried to access this traffic manager URL. So now um, it is going to the East US. And similarly, from West US VM, he is trying to log in and browse it, and it is resolving to that, the nearest one, that is VM West Europe. So
Got it.
basically it will resolve based on the routing we have kept. So this is the lab on Traffic Manager. Yeah. With this, we complete the session on Traffic Manager. Tomorrow I will cover Front Door and Network Watcher. Any
Okay.
questions? Any questions or anything on this?
No, no questions on this. No.
Okay,
I yeah, I worked half on them, so I'm still half back. Three
okay.
classes words to my labs. So most probably by this weekend I'll complete all.
Okay. Feel free to give me feedback because, after some gap, I have come back and I'm giving these trainings. I know I'm little slow, as- and I'm trying to prepare these slides and the content. And yeah, if you have
No,
any
no,
feedback,
you're really up to mark, Ramesh. So it's really easy to understand what you're trying to. So it's helping me a lot. I would say that.
yeah, thank you, Amar.
Mhm.
Okay, Amar, then yeah, actually today is Kartik Purnami, so I need to go to temple. That's why I wanted to close the session a little early.
Yeah, that's fine.
Yeah,
Yeah,
my
go
family
ahead.
is waiting. So yeah, okay then happy evening or good night. Yeah. Okay.
Yeah, see you tomorrow. Bye.
Yeah, bye.